So as we proceed through relativity, we're going to move on to the general theory of relativity. Einstein actually published two major papers on relativity. The first, in 1905, was the special theory of relativity. And then the second came in 1915. And this is the general theory of relativity. Now, colloquially, a lot of people expect the special theory to be better or fancier or somehow superior. That's not the way that it's regarded in math and science. In math and science, general cases are often preferred. A special case applies in one instance or a number of instances. For example, we've seen the Pythagorean theorem, and we've worked on that since elementary school. If we have a triangle A, B, and C, well, we know A squared plus B squared equals C squared. Later on, we learn how to deal with triangles that are not right triangles, and we'll often get the cosine law. A squared plus B squared minus 2AB cosine angle C. The cosine, or the Pythagorean theorem, is a special case of the cosine law. The cosine law is the general theorem. It's the special case because it only works in the one instance when angle C is 90 degrees, because cosine of 90 is 0. So in that one special case, the two work together. But because it is a special case, it's only true in that one circumstance. Whereas the cosine law is always true. Once you've got the cosine law in your toolkit, you don't technically need the Pythagorean theorem anymore, because you could use the cosine law every time and just put in 90 for the cosine, or for the angle here, and that term goes to 0. So that is the difference between special and general cases. So now that we have that distinction, we'll move on to part 2. And as we're moving on, I'd like you to consider this and ask yourself, well, what makes it special versus general? So what limitation have we seen so far in relativity that we may need to overcome?